Hi, I'm Ken Hellebang, engineer with the North Dakota State University Extension Service. In this brief video, we're going to cover information on safely using portable generators for emergency electrical power. The first thing that we'll need to do is to determine what size generator we need or how much electrical power we're going to try to energize. As we're trying to decide what amount of electrical power we need to look at how we measure electrical power. And the term that we use is watts. And so you might look at as for example, a light bulb, that it has a 100-watt rating on it. So that will use 100 watts of electrical power. And as we're selecting what we're going to operate, sometimes we need to make a choice because we may not be able to run everything. We'll have to determine what we really need to run and what we can leave off. For example, if we're using the new compact fluorescent lights, that will also provide the same amount of lighting but for much less wattage. This one provides the light of a 100-watt light bulb for only 23 watts. Now, what you would do then is just to actually add up how many watts you have. So if you have 200-watt light bulbs, you would have 2 times 100 or 200 watts on that electrical use. Sometimes we may not find that it lists how many watts. Many times it will just list the amount of amps that are used and the amount of voltage used. And we can make a good estimate simply by multiplying amps times volts. So for a simple calculation, let's say we're using a 10 amp load on a 120 volt circuit. We take 10 times 120 and that would be a 1200 watt electrical usage. Now there's some times where we're going to be using electrical motors, such as in sump pumps, furnace fans, in the refrigerators, any place that has an electric motor. Not only do we have to be concerned about the operating watts, but we also need to be worried about the amount of watts or power required to start that electric motor. And for example, if we're running a half-horse sump pump as we have here, it will probably use about 1,000 watts of power when it's running, but we might need another 2,000 or 2,400 watts to get it started. And so when we look at our generators, what we want to look at is not only the operating watts, but what capacity it has for starting watts. On this generator, for example, it has a running watts of 3,250 and a starting watts of 3,750. So just a very few additional watts. Now if we go to this other generator, this one has a 5,000 watt running watts and a 6,250 additional starting watts. And so as you're sizing that load, you need to keep in mind that you'll need that additional maybe 2,000 watts to start a large half-horse motor like we would have on a sump pump or on some of our other motors. Some of the appliances or equipment that will have motors might be a third-horse sump pump, for example, that will have a running watts of about 800, but then you need that additional starting watts of about 1,300. You go to a half-horse sump pump, we would be looking at a running watts of about 1,000, but initial about 2,000 watts to start it. A furnace fan blower might be a 3rd horsepower, so again 700 running watts, but you would need an additional 1,400 to start that motor. A refrigerator freezer, again with the compressor motor, about 700 watts for running or operating, but an additional, again, close to 2,000 watts to start it. So take that into consideration as you're determining what size generator you need. There are 2 options for getting the electrical power from your generator to the appliance that you're going to be using. One of those is to use an extension cord. And we're going to talk a little bit about some of the options and considerations with using an extension cord. There typically will be two voltage options. You can either have 120 volt or 240 volt. Some of the equipment may be requiring 240 volt. If you're doing that, that will have a special end on your plug for the cord that you're going to use to power that 240 volt appliance. Probably most of the things that you will use though will be 120 volt, and for that we'll have your typical three-prong plug. And it's very important that we do use a three-prong plug, because that third prong is an equipment ground that protects the equipment that you're working with. And so don't use one that does not have that third prong. We also need to be concerned about the size of the wire or the extension cord that we're using. That needs to be sized large enough for the electrical current that cord will be carrying. And so when we go through and add up for the appliances that will be used on that extension cord, we may find that we're going to be operating with 10 amps. We need to select an extension cord then that is rated for 10 amps. And you can look on the extension cord and it will say what size wire it has, what gauge wire size, and what amps that is sized to carry. And so you need to look at that. For example, a little extension cord like we might have laying around the house on some of our small lights is not adequate. That's a very small wire. It can carry only a very small amount of electricity and frequently does not have that third prong on the ground. So we need to select the cord that is large enough. The other thing to take into consideration is the length of the cord that we're going to be running. That not only do we need to be concerned about the amps that wire is carrying, but the electrical resistance. And if we run an extension cord too far, we end up with what we call a voltage drop. It just means there's not enough electrical power at the end. And so if we were to run, let's say, this extension cord and another extension cord and end up running 200 feet, we may end up with a very low voltage that would cause the motor, a sump pump for example, to what we refer to as burn up. It doesn't have enough power and it would then not function and would be damaging to that motor. So whether we're running furnaces, sump pumps, or refrigerators, anything that has a motor, we need to be concerned not only about the size of the wire, but the length of the wire. And typically, someone at the hardware store or wherever you're purchasing that electrical cord can help you if you have questions. The other thing that we need to be concerned about, particularly from a human safety standpoint, if we're working around any moist conditions, is to use a ground fault circuit interrupter. The ground fault circuit interrupter protects you from electrical faults or electrical shocks, and that needs to go in any place where you have a damp environment. It measures the amount of electricity in that circuit, makes sure that if there's any fault, that it will shut that power off. So it's very important, particularly any damp environments that you might be working in, to include a ground fault circuit interrupter in that extension cord. And they do make units that you can purchase that you just plug into that cord and will provide that kind of protection for you. Another option for getting the electrical power from the generator to a home is to use what is called a transfer switch that is wired into the electrical circuit of your home. And what that does is takes the utility power off the house and then connects to your generator. And so it's very, very important that you use a transfer switch if you're going to be wiring into the house circuits, because otherwise the power from the generator would feed through the house, up through the transformers, back on the line, and could damage equipment or hurt people, your neighbors or linemen that are working on that electrical system. So not only is it law, but it's very important that you include some type of a disconnect from the utility, which is typically done with a transfer switch. Now, a transfer switch, as I indicated, is a part of your electrical system, so it will typically need to be wired in by an electrician. Make sure that you can consult your local electricians and what the electrical codes are, and when you determine how you're going to connect into your electrical power. Now, whether you're doing it with a transfer switch into the household circuit, or if you're doing it with extension cords to the individual appliances, it's very important that you look at the operator's manual on the generator and make sure that you understand, is there grounding that's required on that generator, what they recommend as far as their procedure for correctly powering the home or whatever appliances you're working with. The other thing to keep in mind, as I mentioned, that with our electronics, many of them are quite sensitive to the electrical quality that we're working with. So it's probably a good idea if you have computers to have those computers off, actually maybe unplug them if you're using standby power to power your system. Whenever we're using a portable generator, it's very important that we're aware of carbon monoxide and the danger of carbon monoxide poisoning. Carbon monoxide is an odorless gas. It can affect us without us ever knowing that it's there. Typical symptoms are getting sleepy, maybe getting headaches, but the only way to really know if you have carbon monoxide in your environment is to have some type of detector. But it's critical, if we're using some type of a portable generator, to make sure that that portable generator is moved outdoors. We can't operate it in the garage, even with the garage door open, because the wind can push that carbon monoxide into the home. I know of a family that operated a portable generator in their garage, and they were overcome with carbon monoxide. Yes, I know that the generator needs to be protected from the elements if we're in a storm situation, but we need to make sure that that generator is outdoors. It has to be outside the garage with the garage door closed. Make sure that we have the generator some distance away from the home. But the only way of knowing whether we have the carbon monoxide in the home is to use a carbon monoxide detector. So it's critical, if you're using some type of a portable generator, to make sure that you're using a carbon monoxide detector in the home. So hopefully with this brief video, we've covered some of the information that you need to select the proper size generator and use that generator in a manner that is safe both for your appliances and for you.